If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So we're saying that if AB is the diameter, right, of this circle, right, and C is the center, and if AB is perpendicular to XY, where XY is any chord, right, then we know that XZ is congruent to YZ, aka it bisects the chord, and arc XB is congruent to arc YB, and it bisects this arc, right? So let's go ahead and start this proof. All right, so proof. So we're going to have AB is the diameter of circle C, right? And suppose AB is perpendicular to this chord XY, right? Okay, so as you can see in this picture, I drew these radii CX and CY. So draw a radii CX and CY. And what that does is, of course, since they're radii, we know both of them are congruent. So look at what we have here. We have two right triangles where their hypotenuses are congruent and they share the leg CZ, right? So by the hypotenuse leg theorem, I know this triangle is congruent to this triangle. So let's go ahead and go down. So I know CX is congruent to CY, right? Because they're both radii. I know CZ is congruent to itself, right? Right? CZ is congruent to itself. And I know that this is both are right triangles, so the measure of angle CZX is equal to 90, which is equal to the measure of angle CZY. So these three things together by hypotenuse leg mean that triangle CXZ is congruent to triangle CYZ, right? Okay. And of course, if these two triangles are congruent, this means, of course, that XZ is congruent to YZ, which is part of what I want, right? XZ is congruent to YZ, and I know this central angle here is congruent to this central angle here, XCZ, and angle XCZ is congruent to angle YCZ, right? And since XCZ is congruent to YCZ, that means their corresponding arcs are congruent, meaning arc XB is congruent to arc YB. So I've shown it. Using the hypotenuse leg theorem, right? I know that XZ is congruent to YZ and arc XB is congruent to arc YB, hence proving our theorem.